please forgive me, although lots of microbiome science stuff sounds like gibberish to me anyway. But we'll try to make it all really clear and understandable this morning. But I really appreciate you guys coming out. We've had the great opportunity of working on this area of science and therapy for the last almost 10 years now. And what you'll get today is really a reduction in at least 10 years worth of microbiome research, right? So what I want you guys to be able to do is walk out of here this morning and feel really, really confident that you know how to deal with the gut. Because in all these years of working with functional medicine practitioners, the main question that we get is how do you figure out what's wrong with an individual's gut? And then how do you treat that, of course, right? So imagine your morning, you get your first client comes in, and your first client is someone with Hashimoto's. And then the next one is somebody with severe anxiety and depression. And then the third one is somebody who's dealing with weight issues, with diabetes. Now you know based on your training that all of them have a gut component to their condition, right? But how do you know what is wrong with each of those individuals' guts? And if you can't figure out exactly what's wrong with those individuals' guts, then how do you treat it? So what you're left to do is throw a lot of stuff at it, right? You might do a stool test to try to get some clues. You might throw some prebiotics and probiotics and licorice and glutamine and just kind of see what works, right? And that is difficult. That's problematic. It causes frustration for you. It causes frustration for your clients and patients. But as you start to look at the microbiome science that's available out there right now, over 10 years, you start to understand that there are certain universal dysfunctions that are present and prevalent in almost all of these conditions. So that's what we talk about. And understanding those signature conditions that are present almost across the board will allow you to really figure out how to treat people's guts, no matter what condition they're coming in. So that's where the total gut restoration idea came from. We started working on it about 4 or 5 years ago and really dug into the research to understand what is the universal dysfunction in all of these guts, no matter what the condition is. And I'll show you evidence of that as well. So it all starts, and this is the pathophysiology, right? So almost, I would say 99% of the subjects and clients and patients you deal with have this pathophysiology. So in a leaky, in a healthy gut, everything looks hunky-dory. You've got this mucin layer that sits on top of the intestinal epithelium. Now what's important to note is there's 2 main sections of the mucin layer. This top part, which is kind of the liquid-like part of the mucin layer, it's a less viscous type portion, and that's where all of the microbes should exist in the mucin layer. Then there's this inner part of the mucin layer called mucin 2. And that part is really important because the inner part of the mucin layer is supposed to be a sanctuary that's almost free of bacteria, including your own commensal bacteria. Now, the moment bacteria up here are allowed to migrate through and exist in this inner part, it causes disease, right? In fact, colorectal cancer, 50,000 people this year have died of colorectal cancer. The cause of colorectal cancer is 2 commensal bacteria, E. coli and Bacteroides flagellis, moving from this layer a few millimeters down into this layer and setting up shop. Just that process alone will kill 50,000 people, right? Bacteria going from there to just there. Now, these are your commensal bacteria. These are not pathogenic, devastating, infectious bacteria. They're just in the wrong place. So this structure is really, really important. So the first thing that disrupts this structure is something called dysbiosis. Now, you all are familiar with dysbiosis, right? That term at least. Then the question is, how do you define dysbiosis? What does that mean? So everybody in this room has a different microbiome. If we tested any one of us looking at our chromosomal DNA, we'd be 99.5% similar. If we tested our microbiome, we'd be maybe 50% similar at best. Since everybody has a different microbiome, how do we know what a dysfunctional microbiome looks like, right? Because what may look like a dysfunctional microbiome may be normal to me, whereas it would be dysfunctional to you. So when you're looking at microbiome science, we're trying to look at themes and universal features across the board that dictate dysfunction. The first thing across the board that's universal in a dysfunctional microbiome is low keystone strains. So these are called keystone strains because they hold up the rest of the microbiome. Right? So there was a study done by a researcher at Princeton. One of the conferences I was speaking in is a research microbiome conference. And he did a study, I don't think it's published yet, But basically what he did is took a microbiome, a couple of different sets of microbiomes. This is an in vitro system, and exposed it to 2 or 3 different antibiotics. So broad spectrum like augmentin, Cipro, and what he found was that exposure to those antibiotics within the first 2.5 to 3 hours kills about 99.9% of the bacteria in the microbiome, right? Everything is wiped out. Now, within the next 8 to 10 hours, they all start to grow back, but they grow back in different proportions. Now, that's not the surprising part of the whole study. What was really interesting is that when he took each individual strain that existed in the microbiome and exposed them individually to the antibiotic, what he found was that 99% of them were resistant to the antibiotic. Right? So why in the world would all of them die if most of them are resistant to the antibiotic? So that just shows the importance of the ecology in the microbiome. If that antibiotic can disrupt 1 or 2% of the strains, it can drop the whole system together. Right? So it's like a house of cards that falls apart. And a lot of those strains that tend to be really sensitive to antibiotics are these keystone strains. So keystone strains support all of the other bacteria within the microbiome. They produce compounds that feed the other microbes. They also produce compounds that prevent the overgrowth of other microbes. Like there's a short-chain fatty acid, a branched short-chain fatty acid, that's produced by some of these keystone strains. It's called corparate. Corparate is a short-chain fatty acid that basically limits the overgrowth of pathogens. So these keystone strains are balancing the microbiome by controlling the growth of pathogens. They also produce all of these other prebiotics to feed all of the other commensal bacteria, so they maintain the microbiome. Now, at the same time, they also have a direct impact on the health of the host. So the most well-known of these keystone strains are Akkermansia muciniphila. And I'll talk about what they actually do. Faecalibacteria prosnitzi, just remember that name. A couple of the bifidobacteria species are considered to be keystone strains. One of them is Bifidobacter longa, and the other one is Adolescentes. These aren't all of them, but these are the main ones. These are the most well-studied keystone strains. So the first feature of a dysfunctional microbiome is low keystone strains. Low keystone strains have a significant correlation and even causation to many chronic illnesses. I'll show you some of that data. Now, when you have low keystone strains, you also end up with low diversity. This is the second and maybe the main feature of a dysfunctional, unhealthy microbiome. Diversity in the microbiome is associated with health, is associated with longevity, is associated with low risk for chronic illness. If you have low diversity, you have an increased risk for all of these conditions, including a lower level of longevity as well. So low keystone strains and low diversity. Now, when you start having this dysfunction, then all of the products that these bacteria produce, for example, short-chain fatty acids, start to go down as well. So one of the characteristics that you can see in a dysfunctional microbiome are low short-chain fatty acids. So low butyrate, propionate, and acetate, and then there's all of these branched short-chain fatty acids like valerate and so on. So when you have low levels of this, the first thing that starts to occur is you start to get dysfunction in this mucosal structure. So this inner part of the mucosa that I mentioned here is actually like a thick gel-like layer, right? And it's supposed to maintain that barrier type of function because it's supposed to prevent all these organisms from migrating inward. It's also the conduit in which the microbiome talks to your immune system. So the intestinal epithelium has a lot of immune cells in it, Hammett cells and M cells and all of these immune cells. It's essentially an immune system of its own. And it gets messages from the microbiome about who's living up there, who should be there, who shouldn't be there. There are all of these pattern recognition proteins and all of these things that are transferred through the mucosa and communicated to the intestinal epithelium. The intestinal epithelium, in exchange, will produce antimicrobials and send it up into this outer part of the mucosa to control the population within the microbiome itself. So this conduit for communication, as it starts getting broken down, number one, it allows translocation of bacteria, viruses, endotoxins, mycotoxins, food particles all into this inner sanctum, but it also disrupts this crosstalk between the commensal bacteria and your immune system. So now your immune system doesn't know who should be there, who shouldn't be there, who's the native population, who it should attack. and that includes things like food particles, right? So when you lose the crosstalk and this stuff starts leaking through, these immune cells, especially M cells that are on the epithelium, they freak out because they feel an invasion is coming in. And it can look very much like this illustration. When they sense an invasion is coming in, then no matter what is in this inner sanctum, they recruit and send and make immune cells. So as this flow starts to happen, low keystone strains, low diversity, because keystone strains maintain diversity, you start getting low levels of production of these really critical compounds. These compounds are the ones that maintain the structure. So now when you disrupt the structure, you end up getting what we call a disrupted mucosa. And then because the mucosa is disrupted and things are translocating into the inner sanctum of the mucosa, you end up getting a disrupted mucosal immune response. So the mucosal immune response is supposed to be an immune response of tolerance. If you've ever heard the word oral tolerance, right? Oral tolerance comes from mucosal sampling of antigens. So food particles and all that are sent in small amounts with signals on them, like the secretory IgA bound to them, are sent into this inner part, and your immune cells learn not to attack them. The immune system up here and the microbiome up here is communicating to your immune cells on the inner part not to attack the stuff that they send through systematically. But when stuff floods through, then the only response that your immune system can do is send a bunch of innate immune cells to create an inflammatory response. So you end up getting a disrupted mucosal immune response, and then that continuous disrupted inflammatory response on this inner part really destroys the tight junctions of the intestinal epithelium, and you get a dysfunctional gut barrier. Ultimately, once you have a dysfunctional gut barrier, you get too much LPS and other toxins all leaking through, right? So this is how the process flows. It starts with dysbiosis. This dysbiosis drives this whole cycle and ends up with people who have chronic leaky gut, or chronic leaking in of endotoxins, viral particles, food particles, mycotoxins, and so on. Once you have all of this stuff leaking into what we call the basolateral circulation, you get chronic low-grade inflammatory activation. And that's a feature of most chronic illnesses. So every client that you guys are seeing are in some stage of this. Right? And our whole idea was, how do we reverse this process? How do we clean this up, fix this, improve all of this stuff? And if we can do all of that, we can completely restore almost any gut. So that's the idea behind that. So let me show you some studies. So a lot of these studies I'll show you are review papers. Review papers are really important to look at because they are meta-analysis of all of the papers in the subject, all of the valid papers in the subject, and then they come up with a conclusion, because of course science is done through consensus, right? One single study doesn't prove a whole lot. You have to have a lot of supportive data that proves the same thing. But this paper I like because they talk about beneficial modulation of gut microbiota. It all starts with dysbiosis. And they talk about the disruption of the microbiota, so that dysbiotic type of population is implicated in many conditions and diseases, including obesity, inflammatory bowel disease, irritable bowel syndrome, type 2 diabetes, colorectal cancer, which is an example I gave. And they even suggest that a way of intelligently modulating the microbiome to establishing keystone strains, establishing diversity, could be a huge therapeutic benefit. Here's another review paper that talks about low diversity. They looked at, and this is an inflammatory bowel disease, they look at IBD patients, age-matched cohort who don't have IBD, and the most consistent observation that they found in IBD is reduced bacterial diversity. Right? So they then recommend that therapies that correct this type of dysbiosis can be really promising in IBD. So when you look at the meta-analysis, all of the papers out there, all of this research on IBD, you find that low diversity is a big driver of the condition, and it's a feature across the board in IBD subjects. This is one of the keystone strains, Akkermansia. This is again a review paper. Akkermansia is so interesting. It is inversely correlated with everything in the cardiometabolic realm. Right? So if you have high Akkermansia, you are protected against everything that falls under cardiometabolic disease. That's like 62 different conditions. Of course, it's most of what kills Americans. We're talking about heart disease, diabetes, dementia, Alzheimer's, Parkinson's, all of these things that can fall under cardiometabolic, and obesity, of course, syndrome is protected against by Akkermansia. Now, they've also done interventional studies with animal models and even in humans. when you implant Akkermansia, it actually can reverse the process of diabetes. Right? That's how powerful